After completing this chapter, the learner will know the reasons for the development of inert gas systems, be familiar with the IMO definitions of the common terms used in the module, be aware of the different types of inert gas systems. As the size of oil tankers increased towards the end of the 1960s, the incidence of explosions in cargo tanks also increased. The explosions were due to ignition of flammable vapor in the tank's atmosphere. The ignition source was, in many cases, thought to be the static electricity charge that built up in the tank atmosphere during cargo and ballast operations, and especially tank cleaning operations. These often disastrous incidents led to the introduction of regulations, systems, and operational procedures designed to improve the safety of all types of tankers, not just oil tankers. One of the main changes that came about was the practice of maintaining an inert atmosphere in the tanks during all operations. By ensuring that the tank atmosphere is inert throughout cargo, ballast, and tank cleaning operations, the risk of explosion is minimized, if not removed. This was achieved by fitting inert gas systems on board. Many gas carriers also require cargo tanks, interbarrier spaces, and other spaces between cargo tanks and hull to be inerted. The design and operation of inert gas systems is regulated to ensure safety, with the main regulations being included in a number of IMO publications. The two main publications are the International Convention for the Safety of Life at Sea, SOLAS, and Inert Gas Systems. Further information regarding cargo-specific inert gas system operating practices can be found in the International Safety Guide for Oil Tankers and Terminals and Liquefied Gas Handling Principles on Ships and in Terminals. In the next section, we will look at the IMO definitions for some of the terminology that will be used throughout this module. There are a number of terms used in this module relating to the design and operation of inert gas systems that you will need to be familiar with. Click on the hotspots to see the IMO-approved definitions given in their publication, Inert Gas Systems, 1990 edition. Cargo tank atmospheres are naturally over-rich for much of the time, as they contain too much hydrocarbon gas for there to be a risk of explosion. However, unintended ingress of air can dilute the atmosphere to such a condition that the risk of explosion is present. It is therefore considered safer to maintain cargo tank atmospheres in an inert state. There are different systems available to provide inert tank atmospheres on board ship. The choice of system for a particular vessel is determined by such factors as the machinery installation and the cargo characteristics. The main types of system are shown here, and you can click on the hotspot to learn more about each of them.